Hello everyone and welcome for Turbo Machinery lecture number 1 for the topic that is steam turbine. So let's see what is the syllabus for steam turbine. So basically in the steam turbine we have to learn the basic about steam turbines, classification, then what are the different type of compoundings to be used for turbine, that is impulse turbine and reaction turbine. Then to understand the velocity diagram we need to based on the basic conditions we have to learn the velocity diagram, which we have already seen similar kind of diagrams in turbines, that is water turbine. So here also same kind of velocity diagrams has to be considered in impulse turbine and reaction turbine, but in case of steam turbine we are using combined type of velocity diagram. In steam turbine, impulse turbine, we have to learn the simple stage, that is single stage numericals on D level turbine. Then degree of reaction and Parsons turbine has to be considered in the case of reaction turbine. And based on the Parsons turbine, we have to see the numericals. So the most important question, what is engineering? Engineering is nothing but the person or the uh, person who can find the different type of applications to apply a scientific knowledge. It related to applying the various kind of theorems, various kind of uh, knowledges related to material mechanics, chemical, then etc. That is a scientific knowledge which can be applied to find a particular solution that we can consider as that we can say as an engineer. Now basically we are considering three type of Newton's laws. First law, an object will not be changed its motion unless and until the force has to be act on it. The second law, in the state that the time rate of change of momentum of in a body is equal to in the both magnitude and direction of the force imposed on it. And third law, when two body interact, they applied forces on each other, which are equal in magnitude and opposite in direction. Then the basic requirement of any steam operated machine, that is steam. So what is a steam? Steam is nothing but it's an possesses properties like a gas which having pressure, volume, temperature, and internal energy, enthalpy, and entropy. So these are the basic properties which is need to be considered while considering the perfect s- gas. But the pressure and volume temperature of the steam as compared to the vapor are not connected by the simple relation or with the help of simple expression by the characteristics equation of a perfect gas. There are various types of steams and heats which need to be considered. Sensible heat. The heat absorbed by the water in attaining its boiling point. That is called as a sensible heat. The latent heat. The latent heat is nothing but absorption to convert boiling point into the steam. Okay, so that is the latent heat. So initially up to water has a boiling point of the 100 degrees centigrade. To reach water from normal temperature to 100 degrees centigrade, whatever the heat is, it can be utilized, it can be absorbed. That is called as a sensible heat. And from 100 degree, it can be converted into steam. So whichever the additional energy or heat is required, convert this boiled water into the steam, it is called as a latent heat. Now there are three types of steam, that is a wet steam, dry steam and superheated steam. The wet steam containing some quantity of moisture that that contain the water particles inside the steam. Second one is dry steam that must not have any um, moisture content. And third one is the superheated steam. Dry steam, when heated at a constant pressure, it attains superheated condition. The property of steam is totally depend upon its pressure. This is a basic steam power plant process is shown over here. Initially, it begins with the we are applying uh, a simple. Just a minute. Okay. So initially we are importing the basic coal that is required to give an input the heat energy towards the water in the boiler, which is shown over here. So basically, when we apply the latent heat, initial heat to convert water into the steam, that steam is again which is continuously overheated, that can be assured up to the superheat level. That steam we can utilize that steam we can utilize over the steam turbine. Look at here. The steam turbine can be used the steam generated inside the boiler, and that velocity of steam, pressure and velocity of steam is converted into the mechanical energy, that is mechanical movement of an turbine. Okay, the and kinetic energy of the steam it is converted into the mechanical energy or mechanical movement of the turbine, which is connected with the generator, and the generator can convert this mechanical energy into the electrical energy. Further, it is connected with the transformer, and this transformer is connected with the transmission line, that we can say a grid. Okay, after the utilization of a steam and kinetic energy of the steam, it can be goes to the cooling tower, where the temperature of the steam is dropped down till to the warm water, and further it is condensed inside the condenser, and it converted into the cold water. And this water reservoir is always filled with the help of different pumping station that we can uh, supply this water from nearby the supply resources. Now next, steam turbine. You can look at here a wheel of a steam turbine. The steam turbine, as I said, it convert the energy of the steam, that is a high temperature steam and pressure, into the mechanical, which further goes to conversion of an uh, mechanical power into the electrical power. So basically, steam turbine converts the heat energy that we have already seen, which is nothing but converted into mechanical energy. Further, it is converted into the electrical energy. So this is nothing but we are applying over the Newton's second law. That is, the force is proportional to the rate of change of momentum. That is nothing but mass into velocity. If the rate of change of momentum is caused in the steam by allowing the high velocity of jet of a steam to pass over the curved blade, the steam will be impart a force to the blade. If the blade is free, it will rotate in a direction of the force which is to be applied. Okay, you can look at over here where the steam is passing over the blade surface, and based on that the um, blade is start rotating in the direction which the steam force has to be applied. In the high pressure steam, the boiler is expanded in the proportional shape which passage is required. It is called as a nozzle, which is shown in figure. These nozzles are fixed in casing due to fall in pressure of a steam in a nozzle. The thermal energy of the steam is converted into kinetic energy. The steam with a great velocity now flows over the set of curved plates, which is shown in figure. Due to the fall in pressure in the nozzle, uh, this converted that thermal energy is converted into kinetic energy, as we discussed. The blades are attached in a periphery of wheel that called as a rotor, which is keyed to the turbine shaft, as we can see in the right side of the figure. On the gliding over the curved blade, the steam undergoes a change in momentum, which imparts a force on a blade. This force has developed or caused the wheel to move in the direction the force is applied. The turbine shaft is rotate according to the direction of the steam. So you can see the nozzle. From the nozzle, the high pressurized steam, high velocity steam is passing over to the blades. Okay, and based on that, the rotor has rotate in the direction of the force applied. So there are some advantages and disadvantages of steam turbine. So basically, the ability to utilize high pressure and high velocity steam, but there is a big disadvantages of this one is it can be rotate with the high speed up to so means 20,000 rpm, which is very far too much difficult to convert this 20,000 to 30,000 rpm speed in into the with a generator, and it can be converted into the electric energy. It is quite difficult. So for that we have to attach the mechanical devices, or you can say a gear train, which can convert or maintain the speed which is necessary to generator, uh, so that it can convert the mechanical energy into electrical energy. Okay, now it can steam turbine has an advantage that high component efficiency is to be considered. Then it's having a high rotational speed, as I just said, that it can be rotate up to 20,000 rpm to 30,000 rpm. Uh, when we visited over the steam Mahajanko, at that also the person was also said that it can be rotate up to 30,000 rpm. Okay, the smooth it can work smoothly and near about less vibration, or you can say vibration free operation. No internal lubrication is required as the rotation parts are rotating only in a single direction. The oil free exhaust stream is, if oil is not used for lubrication, then oil free exhaust stream we can use, and which can be further we can repeatedly use for, we can say, reuse. We can use reuse this stream. Can build the larger, we can generate power up to the 1500 megawatt. So let's see, discuss about the disadvantages. So disadvantages of the steam turbine, it cannot be work on slow speed application. As I say, it can rotate in 20,000 to 20,000 to 30,000 RPM, which is too much and which is not able, a generator can get that much speed and convert the electrical energy. So we need to apply, or we can slow down the speed for power generation application. So for that we are using reduction gearbox. The steam cannot be made reversible. You cannot convert. You can directly uh, reuse this steam in the direct action. It is not possible. The efficiency of small and simple turbine is quite poor because there are lots of process to do. So the total efficiency is getting reduced. Now, what are the different applications where it is used? First, power generation. Then next one is a refinery or a petrochemical application, pharmaceutical applications, food processing applications, then petroleum gas processing application, pulp and power mill, even though we can use in sugar mill also to create a sugar, waste to energy, which in such kind of applications we are using steam turbine. Now, how you can select a steam turbine? So, whenever we are choosing any component, we should have a consider some factors. First, efficiency. The turbine which we are selecting having a higher efficiency as possible with the other. Then life, because we are initially apply invest so much money, so the life should be much more so that we can uh, work or we can regain the investments. Then power density, that is a power to weight ratio, it should be as low as possible. Then the manufacturing and maintenance cost must be uh, as less as possible. Now we have to consider, we have seen the classification of the steam turbine. The steam turbine is basically classified into various categories. Initial, Initially, the principle of operation, or you can say impulse turbine and reaction turbine, that is the stage of design and principle of operation. According to the steam supplied and exhausting condition, the condensation or non-condensation, that is back pressure. Then automatic, you can say control the extraction. Then mixed pressure and reheat. These are the some uh, types based on the supply and exhaust condition. Based on the casing and shaft arrangement, it could be single casing, tandem compound, or cross compound. Then, according to the method of compounding, there are three types: velocity, pressure, and combination of velocity and pressure. Then, number of exhaust stages, which is parallel, two flow, four flow, six flow. The direction of the stream, axial flow, radial flow, or you can say tangential flow. Then stages, single stage, multi-stage. Then by the steam supply, we can have a stationary turbine with its constant speed, a stationary turbine with the variable speed, or you can say non-stationary turbines using steamers, ships, and railway locomotives. Then there is a one more type according to the type of governor use, that is a throttle, bypass, nozzle, or you can say combination of throttle, bypass, and nozzle bypass. Then there is a one more classification is based on the bar pressure inside developed inside. That is low pressure, which can be considered up to 2 bar, medium pressure, which can be considered up to the 50 bar, high pressure, which can be considered above the 50 bar and below the 220 bar, and the pressure developed in the sea steam above the 225 bar. It is called as a supercritical pressurizer steam. Now we will see the different stages which a rotor having. So initially there are to be considered two type of blades. One is a fixed blade and second one is a moving blade. The initially the series of the fixed blade is wounded, or you can say gear placed over the rotor. After that, the series of moving blade has to be placed, and vice versa. The same sequence has to be followed with the each and every set. Now, if it the in the bottom, if you look at the pressure velocity diagram with respect to the moving plate, when at initially the pressure is too much high. At initially, the pressure is too much high. So when it is passes through the fixed blade, when it is passes through the fixed blade, the pressure is suddenly get dropped. When it is kept, it is suddenly get dropped down, and the velocity, that is absolute velocity, is suddenly get increased. Is suddenly get increased when high pressure, high temperature steam is passing through the fixed plate. In the second stage, when it is uh, starting passing after the exiting the fixed blade, then it has to be reached over to the into the moving blade. Okay, in the moving blade, again the pressure, the velocity get down, the velocity goes down, and the pressure is constant. In this region, in the moving blade, the pressure is constant and the velocity is suddenly get dropped down. In the second stage, if you observe, again it is passing through the fixed blade. So जैसे ही ये fixed blade में चली जाती है, again there is a variation in a pressure, that the pressure is going to be down and the velocity is get increased in upward motion. Then it is passes to the moving. The same process happen, that the pressure is constant. At that time, the velocity get down. Now, why this velocity get down? Because the steam is transfer its velocity to the moving plates, and because of the high pressure, high velocity steam, the rotor is rotating. That is conversion of heat energy into the mechanical energy of a moving plates. Okay, so here the kinetic energy, which is converted into the shaft mechanical energy. Okay, so in this manner, the steam turbine it works. Okay, so it is a basic procedure how the steam turbine is going to be worked, that has explained over here. Now next you can see the basic constructions of the blades of an impulse turbine and reaction turbine. Throughout this series, we will discuss about the impulse turbine, reaction turbine only, and their types. Now there is a difference between impulse and reaction. As we know, we have already seen the difference between impulse and reaction turbine. That is a water jet turbines. Okay. So here we are also again discussing same thing, but in case of steam turbine. Okay. In impulse turbine, the process of complete expansion of the steam takes place in the stationary nozzle, and the velocity energy is converted into mechanical work on the turbine, which can say work blades of the turbine has to be uh, get an emotion. Okay, so in the reaction turbine, the pressure drop with an expansion and generation of kinetic energy takes place in the moving blades. In the reaction turbine, there is a guide blades instead of nozzle, which converts the pressure energy into the kinetic energy. The power rating of the impulse turbine is small, but in case of reaction turbine, it is high. Okay, the rotor diameter is also that a simple way. The construction of the impulse turbine is small, in but in reaction, it is high. The dimensions of all overall dimensions of the reaction turbine is much more as compared with the impulse turbine. The example is of impulse turbine is the level turbine and the reaction turbine, which we uh, are going to be studying further. Now, impulse turbine and reaction turbine, you can simply see the action. Now, look at here in a impulse turbine, the pressurized steam is directly impinging over the curved blade of an impulse turbine, okay, which is converted, which will further transfer the kinetic energy of that steam into the mechanical energy of rotor. Okay. Now look at here. The nozzle is used, which converted the high pressurized uh, steam passes from the nozzle to the curved blade. Okay, from here to here. Now here you can initially see when the steam entered inside the nozzle, the pressure is getting dropped and the velocity is getting increased. Okay, so that is very important. In the initial stage, when steam is passing through the nozzle, the pressure is get drop and the velocity it get increase. Okay, when it passes over the blades, the velocity transfers its motion to the rotor, or you can say uh, uh, to the blade. Okay, and that rotor get movement in the direction of the force applied. Okay, so in this case, the velocity get drop down, and in the same condition, the pressure is constant. The steam pressure is constant. But in case of reaction turbine, in the case of reaction turbine, when the steam enters in a fixed blade, the steam enters in the fixed blade, the pressure get down, the pressure get down, and the velocity get increased. The velocity get increased. When the steam exit the fixed blade and enters inside the moving blade, it transfer its kinetic energy to the rotor and the velocity get dropped down. As compared to the impulse turbine, the pressure is also get dropped down in reaction turbine. But in case of impulse turbine, it is constant, the steam passing over the blades. Okay, बट यहाँ पे ऐसा नहीं है. जैसे ही मूविंग ब्लेड से फिक्स ब्लेड से स्ट्रीम मूविंग मोड में मूविंग ब्लेड्स पे के ऊपर से पास हो जाती है, वहां पे भी सडनली प्रेशर ड्रॉप डाउन हो जाता है. ओके, सो द स्टीम प्रेशर इज कंटिन्यूसली गेटिंग ड्रॉप डाउन in the case of reaction turbine, but in the case of impulse turbine, the pressure, the velocity get dropped down when the steam is passing over the plates, but pressure will be same throughout the process. Now next, this is an impulse turbine, the basic construction And the reaction turbines construction, the velocity and pressure. The if you look at to the entry level, the red line shows the pressure drop down based on the process, and blue line shows the velocity increment, and it passes over to the moving blade. Okay, so this one is a nozzle and this one is a moving blade. But in reaction, if you look at multiple moving and rotating, fixed and rotating blade series are uh, collectively connected one by one. The pressure is continuously getting dropped down, and in velocity, it is getting dropped down with the moving blade, and again get increased in a fixed blade. Okay, this process is continuously working on. The impulse turbine, mostly we have to learn the level impulse turbine, and in reaction turbine we have to learn Parsons reaction turbine. Okay, okay. I hope you understood what is the basic classification of the reaction turbine, and what are the how the steam is travel from in the case of impulse turbine, रोटर पे डायरेक्टली पहले नोजल से आती है, फिर रोटर पे मूविंग ब्लेड पे चले जाती है, एंड देन एग्जिट हो जाती है. बट इन रिएक्शन टर्बाइन पहले फिक्स ब्लेड में आती है, फिर मूविंग ब्लेड पे चली जाती है. सो इट इज कंटिन्यूस प्रोसेस, विच आई होप you are clear.